guys, it's good to see you all. I was thinking, since the Avengers broke up, and since times are so rough in the world these days, I thought maybe we should try to put a new group together. We could try to help students with their homework, and then we could fight evil in our spare time. I know, Thor, you could help with foreign languages because you speak Groot.
You speak Groot? Yes, the total on Asgard who was elected.
I am Groot.
But what do you guys think we should call this new group?
The Revenges.
Revenges?
Because I'm getting revenge. You're getting revenge. And what do you want revenge?
I'm undecided.
I don't know about that name. I think that's a great idea. I agree with Groot. I think the group should be called the Math Vengers.
Cool? Cool. So cool.
I appreciate you guys bringing me into the group. So, for Thor especially, I heard about all your problems with your sister breaking your hammer, and she really did sound like the worst. So, I have a gift. For you. What do you think of this weapon?
A king's weapon. Meant to be the greatest in Asgard. In theory, it could even summon the Bifrost. It have a name?
Math Breaker.
He needs the axe.
He needs the axe right now? Don't worry, I got you, Thor. Here you go, pal. He needs the hammer now? Here you go, Thor. It's not the hammer, it's the axe. Hello, 7th grade. Today we're talking about a thing called like terms. So there's two papers for this. One is a paper that says notes that we'll just work through together. You could use this to watch the video and help you stay on track. Then there's a homework paper that's just like this that follows. So first thing that you need to know is that like terms have exactly the same variables. So what you might want to do quickly on 1 to 10, if you think you understand what I just said, is decide on 1 to 10 at the top here whether each group is like or unlike. Again, like means they have the exact same variables. Unlike means the variables are different somehow. So you could try to make that judgment and then on pause and I'll still be talking. Or you could listen to the first few and then pause when you think you have the hang of it and do a little bit of self-test. But you're always going to do this, I think, better if you kind of self-test yourself a little bit by pausing and trying and then coming back to it. But here's the answers to the top 10. 1 is unlike because it has an X in one and a Y in the other. And we want to have the same variable and we have two different letters. The variables are the letters. So 1 is a no. The 3's are the same. We don't care about that. Okay, the numbers in front are called coefficients. Those don't matter for this game. 2 is a no, because 1 has an X, 1 has a Y. Different letters? No. 3 is a yes. They both have X's. 4 is a no. The one has X to a second power, meaning there's 2 X's there. The other one has 3 X's there. Those are different. So 4, no. 5, yes. Even though I changed the order, remember when things are next to each other, that means they're multiplying, and you can change the order of multiplying anytime that you want to. So the first one has an X and a Y, the second one has an X and a Y. So yeah, 5 is like. 6 is unlike because the one had a B and the other didn't. They each have A's, but the B makes a difference, so 6 is a no. 7 is a no. 7, the one problem has 2 A's and 1 B. The other one has 1 A and 2 B's. That's different. Okay, the first one had an extra A, the second one had an extra B. 7 is unlike. 8 is also, no, 8 is like 5. 8 is like. 8 has an A and then 2 B's. The other one has 2 B's and then an A. The order doesn't matter. Those are the same thing. 9 is like because they don't have variables at all. And since neither one has a variable, we'll consider that the same. And then 10 is unlike because 1 has a variable, 1 doesn't, so that's no good. Second thing we'll be looking to do is to do a thing called combining like terms. Combining like terms just means that we're going to use the adding rules on the coefficients. Again, the coefficients are the numbers in front of the variables. By adding rules, I mean this. If you have two positives, you get a positive. You add them. If you have two negatives, you get a negative. You add them. When they're different, that's where it depends on which one's bigger, and we subtract them. So a problem like this, we're focused on the coefficients. The coefficients are positive 6 and positive 3. Put that together, that would be positive 9, and the x part of that does not change. If you think you have the hang of that, try a couple. If you don't, listen to a few more, pause when you think you have it. Until we get to that line, they're all about the same. So here we're going to go negative 4 and positive 7. The signs in front of the numbers go with them. So 4 is negative, 7 is positive. If we add a positive 7 and a negative 4, that's a positive 3, and we just keep the x on it to keep them like. Here, 8 is negative, 2 is negative. When we have two negatives, we get a negative, and we add them, and leave the x on there. This has a positive 7 and a negative 10. The negative is bigger by 3, leave the x on it. This has a positive 7 and a negative 3. The positive is bigger by 4, leave the x on it. And then here's a secret fact that you might or might not have known. If you don't see a coefficient, invisibly there's always a 1 there to help you. So 9 plus 1 makes 10, and leave the x on it. Once we get to here, we have to be a little more careful because we have double the work to do, and you have to get the right things with the right things. This positive 2x is like with the positive 4x. That can make a positive 6x. This positive 3y can go with the positive 5y, and that's a positive 8y. I don't always in my life write every positive sign as a plus, but here I need that plus to just join these together. I need some sort of a symbol to join them. If it's a positive number here, I do a plus. If somebody else had done the 8y's and noticed that first, that would be fine. If you noticed the 6x second, that would have been fine. You'd have put a plus there because 6 was positive. Both of these answers would be scored correct. Generally, you'll see people do the x's then the y's because of alphabetical order, but it doesn't have to be that way. You can go any way you want. If you think you understood that, you're going to be good pretty much through the whole rest of this. You could pause the video and self-check, or you could just listen to me some more. So this has an invisible 1. 2x's and 3x's can make 5x's. The 1y and the 2y can be a 3y, but I can't have just a big gap here. Since that's positive, I need a plus to just help fill the gap. Negative 2, positive 7 would make a positive 5 for the x's. And the y's just eliminate. There's a negative 3 and there's a positive 3. That would make a 0. I'm not going to write anything about zeros. I'm just going to get out of there. I'm just going to quit. Get out. 2 with negative 8 would be negative 6 for the x's. A positive 3 and a positive 2 is a positive 5 for the y's. Here I have negative 2 and negative 4 for the x's. That makes a negative 6, because when you add two negatives, it makes a negative. We add them. Negative 3 with negative 5, that's negative 8 for the y's. This next one, 2x has no like term, friends. If that happens, just copy it unchanged. Don't do anything about it, just leave it alone. Then combine everything else. Negative 4 with negative 5 would be negative 9. But negative 9 gets somewhat overcome by the positive 6. When we're different signs, we subtract. That would be a negative 3y total. Then I went to 3 letters. So x's, there's 3's, and there's negative 6's. So that's a negative 3 when we add. For the y's, there's positive 4, negative 2. When they're different, we subtract, so that's 2y. z's, -5 and -3 is -8 for the z's. Next one, I need to remember some invisible ones. 3 and 1 makes 4 for the x's. -1 and -4 is -5 for the y's. For this column, x's, I have a +2 and a -2, so that's a 0. I'm not writing it. -3 and -3 is -6 for the y's. That's only a 0 when they're positive and negative, but matched numbers. So the 2's, positive and negative, eliminate. But -3 and -3, same signs, add to make -6. Here I have x, x, and x. So if I go 5 and 2, that's 7. But a -7 with a +7 is an elimination. It just leaves me the 3y. Here I need to remember a 1. -6 and -6 is -12 x's. A +1 and a +3 is a +4 y. X's there, -7 and +3 is -4. The y's at the end, +2, -8 makes -6 for the y's. The last one has some powers. The powers don't do anything. If I had gone through here and had 10, 10 on the x's, this x would just have a 10. If the y's had 9 and 9's, this answer would just have a 9. The powers are meaningless other than just make sure they match. I need to insert a couple coefficients of 1's there. In the x's, -4 and -1 is -5. The x's all had 10's on them, so just keep that there. -1, +6. That's where it depends on the bigger, which is the +6. We subtract to get down to 5, and then the y's had 11 on them. If that makes sense to you. If it doesn't, email me, we'll work it out. On the worksheet, when you go to do the homework, there's only the first few, I believe, that'll ask you, are these like, yes or no? And then, let me actually grab that paper real fast. Wrong pile. So many piles in the room these days. Piles everywhere. Maybe I already took that up here somewhere. I don't know. I don't see it. No, here it is. All the way around the world. You got a tour of the room. The first one's just the definition. What are like terms? Say they have the exact same variables. From 2 to 10, you're either going to say yes or no, whether they're like or unlike. Starting on 11, you're going to get all these kind of XY answers like I did on the board, X's and Y's and such. From 11 to 40, that's doing that. So, see you later.
Call. It's not that easy.
Hello, Ted? Hey, no, this isn't Cap's phone anymore. This is the Math Wizard. What's up? Yeah, Cap isn't here. But I have been thinking about that problem you were having with your time travel machine. I think if you would try a Mobius strip, I think that might be the key to the whole operation that could bail you out. Yeah, I think that would work. All right, yeah, hey, no problem. Glad to help you out anytime, bud. See ya.
Sorry, Mr. Stark, but I'm the real Iron Man.